Hello everyone. In this second example of finding canonical covers, we have a bit more of a complex query, but we're going to be looking at mainly BC implying AD. In this one, we have a relationship A to E, and we're giving this original canonical cover. We're going to first start off by looking at the right-hand side of each of our implications here. So we have D, AD, B, A, and D. Excuse me. And from here, we're going to do our first step, which is going to apply unions to each of these attributes. So if we look at any extraneous attributes, we see that AD is one here. So we're not going to do anything on the left side. We're only going to split off A and D. This is going to generate a new canonical cover for us. It's going to be A implying D, and all we added was BC implying A and BC implying D, okay? Don't do anything with the left-hand side just yet between these steps, because down the line that might cause issues if you try to do too much in one query or step. Now, if we take a look at our right-hand side, we see that we have no longer any extraneous attributes. So we're going to jump to our left-hand side, and we're going to check if there's any extraneous attributes there. We have A implies D, C implies B, so forth. It looks like BC implying A and D is the only one that have extraneous attributes. And again, the entire purpose of this part is we're going to say, can we remove either attribute B or attribute C from this implication or from this functional dependency to try to remove any extraneous items to make it more minimalistic. In other words, is C required for this relationship to be true, or can B by itself figure out C somewhere else? Okay, so if we go ahead and try to look at B, the closure of B, so essentially if we try to remove C from here, we're going to notice that B by itself implies itself using reflexivity, but if we see up here, A implies D is not really what we want. We have another element here of BC implying D, and we know that we have access to B, but we still don't have access to C whatsoever, so we actually can't do anything with this relationship either just yet, okay? We also see that we have C implying B over here. That doesn't really work for us, and these two are with E, so it doesn't apply. So right now, only using B, we know that it only implies itself. So right now we could say that C is not extraneous, and we need it in this relationship. Now, if we go for the inverse here, we have BC implying A. We can ask, is B extraneous? From here, we can notice right away that C is going to imply itself. We could probably add that in there. And we also notice that C is going to imply B. Now again, where am I getting this closure from? Just kind of think of it by C by itself. So C implies C, and C also implies B. And I want to show you something that you might not need to do too often, but it is a good trick here. We can apply some axioms to generate a new relationship here. So we know that C is going to imply C and B. Therefore, we know that C can also imply CB, okay? So what this means for us is that we can use CB or also BC here to try to look at some other elements. And again, we're not looking at the BC implying A, but we notice that BC actually implies D, okay? And so because we know that C implies itself and implies B, it can imply BC, and we know that BC implies D. And from there, we could also try to get another element here where we have BC implying A as well. So I said earlier that we won't look at that one, but essentially if you know that you have BC implying if you know that C can imply both of your attributes, you can then try to get the other attribute there too. So one more thing that we're missing here is E from all the elements. So BC implying A isn't necessarily good for us for trying to get a closure of every attribute. But what we're looking for again is we're trying to ask, can C imply B so that we don't need it in our relationship? And what we see down here is that C does imply B in this relationship right here. So we can actually remove it, and B is extraneous in this relationship. Cool. So what this would create for us, I don't have it here, but essentially what it would create is it would create BC over to A, would then become C over to A. We're going to repeat our process down here for BC implying D. We notice again that B implies itself. Can we see if B is extraneous? We notice that C can imply B from over here. So B is extraneous in both of these relationships, BC implying A and BC implying D. Cool. So this would generate a new functional dependency list for us, or canonical closure, where we have A implying D, C implying A. Again, that was from up here. We removed the B because it's extraneous. C implying D, removed the B because it's extraneous, and then we kept the remainder of the other items there. Okay. So now we have this new canonical cover, and because we've removed all extraneous attributes from our canonical cover, the last step that we have to do is go through any changes that might be needed, and we try to look for redundancies. So is A to D redundant? Essentially, can we imply D without this dependency inside of our attribute closure? So if we look at our attribute closure here, or excuse me, if we remove A implying D and we create a new closure canonical cover with this one, we notice that A by itself is going to imply A. But if we go elsewhere, C implies A, C implies D, it looks like we can't get A anywhere else inside of this closure. So because we cannot calculate further, or we can't calculate D any further, A implying D is not redundant. So is C implying A redundant? Can we imply A without this dependency? Let's remove C over to A, and let's try to look at this. So C is going to imply itself. C is also going to imply D. C also implies B. And let's see what we can do here. So we have C, B, and D, but we can't do anything else here. So C over to A is not redundant because we're not getting that A value anymore. Okay? So again, you're not trying to get all the attributes calculated in your canonical closure, or excuse me, in your closure of this attribute C. You're essentially saying, can I somehow get to whatever this original relation is implying without needing this one here? So again, if A implies B, can I somehow get B without needing that relationship? Is C is C implying D redundant? Can we imply D without this dependency? So let's see here. So we noticed from earlier, we actually were able to get C and D up here, but let's take a look at our relationship here. We notice A implies D. That doesn't work for us too well right now, but we know C implies itself. C also implies A, and we also know that A implies D. So using transitivity here, we can say C implies A and A implies D, then C implies D. So we can actually get to the D dependency. Excuse me, we can imply D as a dependency without needing C implies D. So again, we can't reach E, but we can get to D, so this is redundant, and we're going to update our F+. And again, every time that I remove something here, I transferred it back to our original one because we didn't remove it, but now I'm going to remove it to this new dependency. And we can see here we removed something that was redundant. Now I have A implies D, C implies A, C implies B, E implies A, E implies D. Okay. So now we can keep going because we already did C and the first two earlier. So what we're going to ask now is C implying B redundant. Can we imply B without this dependency? So again, C is going to imply itself. C also implies A. C also implies D. Let's see what we can get here. We get CAD, but we cannot calculate anything further, and B is not accessible anywhere else in our code. So it's not redundant, and we're going to need it. We're going to move on to E implying A. Is this redundant? We have our new canonical cover, or our makeshift one for right now. We're going to say the closure of E implies itself. It is also going to imply D over here. But it looks like we can't go anywhere further because D doesn't imply anything else. So we're going to probably be stuck with E and D. And since we can't go anywhere further, we're going to need A here as well. Now for the last one. E implies D. Can we imply D without this dependency? Well, we already know from earlier that we had a canonical cover up here where we got the E, but let's take a look at this new one. A implies D, C implies A, C implies B, and E implies A. And we notice here, if we take a look, E is going to imply our A, and A's are going to imply our D. So even without this dependency here, we're able to get to our D value. So we know that this guy is redundant. Okay? And so what that will tell us is because I can access the dependency of D using transitivity, this is a redundant implication here. So now my final canonical cover, oops, it might be a little hard to see. So let me move this up a tiny bit. There we go. is going to be F is equal to A implying D, C implying A, C implying B, and E implying A. So that's my canonical cover, and this was a bit more of a complex process, but shows you how you can get there. And again, we've reduced it from the previous versions that we had at the very top. So I'll make this a tiny bit smaller for us there to get to it there. Okay. So again, this is kind of all you need to do for the work that you're going to be showing, something along the lines of this. You don't need to go into so much writing as I did, but that's more so for your sake to help out. One more thing as well is that there's some tricks that you can pick up on that are, like I said, straightforward when you get the hang of it. You'll notice here, when you say C implies B, we notice that B can't be implied anywhere else because it's just not anywhere implied elsewhere. So there's no B implying another value, or there's no other relationship implying B. So you can assume that C implying B is going to be important because it's the only one that does it. So there's small things like that where if you feel pretty confident that you can find those quickly, you can write that down. Otherwise, to be safe, you can use this process too. Great. So this is 2 examples of how to find a canonical cover. You won't be asked any further than to do this, and if you need more examples or help, please let me know. Thanks.